Okay, everybody, so let's talk about average rate of change.
All hands up.
All right, average rate of change. So here goes our pre-calc boot camp. So let's go ahead and take some notes here. Okay, so average rate of change of a function is essentially how much a function is changing over a specific interval. Average rate of change is the same as the slope of a secant line. Okay, get that down in your notes, write it nice and big. Okay, let's look at some examples. So let's find the average rate of change of a function that's pictured here over the interval -1, 1. Okay, so remember that's an interval, that's an x to an x. So an x of -1 to an x of 1. Okay, so go ahead and look at the graph. Find where x is -1. Locate that point, okay? And so it looks like when we're at -1, it looks like there's a point at 2, and then when x is +1, the y-coordinate, the corresponding y-coordinate is a 5. So there's a point at -1, 2, and a point at 1, 5. Let's recall our slope formula. There it is. Go ahead and pause this video if you need to. Write it down. Okay, and so then if we go ahead and use our slope formula, we've been using this since Algebra 1, we're going to get 3/2, and that's our average rate of change on that interval. How much the function itself is changing from -1 to 1. Okay, let's look at a couple more examples. So let's try this one on the interval from 0 to 3. So what's the point at 0? And what's the point at 3, right? So when x is 0, there's a point at 0, 1. When x is 3, there's a point, or the corresponding y rather is 8. So there's also a point at 3, 8. Okay, so then using our slope formula, we'll go ahead and punch this out and we'll get 7/3. Let's do another example. Okay, this time with no picture. Okay, so you've got f of x equals x squared minus 2 on the interval from -2 to 4. Okay, so we're going to sub in -2 into the f function and get 2, and we're going to sub 4 into the f function and get 14. And if we go ahead and use those two coordinates in the slope formula, we'll get an average rate of change of 2. All right. Okay, one more example before we do the we and the you all, and then we're done. So let's find the average rate of change for g of x equals -1 over x plus 3. We got the interval -2, 0. Okay, so we're going to go ahead and sub in -2 and get g of x is -1. And when we sub in the x is 0, we're going to get -1/3. Okay, that means we have points at -2, -1, and 0, -1/3. And if we use that in the slope formula, right, we're going to arrive at an average rate of change on that interval from -2 to 0 of 1/3. Okay, finally, almost done on the we problem. Go ahead and pause it if you need to. Why don't you pause it and give this one a shot, see if you could do it yourself. Okay, so here we go. Solution, if we sub in -2, we're going to get a point at -2, 1, -1 rather. And if we sub in a 0, we're going to get 0, 3. We're going to use that in our slope formula. And we're going to get this, the slope is 2. But now take a look at this one. What we're actually looking for is the whole equation of the secant line. So now we got to go to our linear formula, y equals mx plus b. We know what the slope is. So pick one of the points. I went ahead and picked the -2, -1 point, sub that in, solve for b, b is 3. Now we know the slope, now we know the y-intercept, so write out our equation, and there it is. All right, and then I just wanted to give you all a visual, so go ahead and check this out. So of course that parabola, that's in red, right? And we found the secant line, that's the blue line that you see there. We found what the equation of that line is, and you can see that it goes from -2 to 0, right, on the interval, on the x interval, okay? All right, so last one, go ahead and pause it, give this one a shot, pause it. All right, and if you did it correctly, you should be getting y equals x minus 1. And then just to, again, give you a visual of what you just found, right? You found on that interval from 0 to 1, you found the equation of that purple line, okay, as it intersects essentially that cubic function. All right, so good luck and go ahead and get to the practice.